We're going to take a look at the development of the quadratic formula, and to start to solve for the letter x. Here we see standard form of the quadratic equation, where a is the coefficient of x squared, b is the coefficient of x, and c is your constant. Now, to solve for the letter x in this equation, we're going to use the completing the square pattern. And we start off by completing the square of taking the letter c and moving it to the other side as a negative c. So taking it from this side to the other, we just change its sign. And then we're left with ax squared plus bx, and we don't have a c term on this side because we moved it to the other side. Now, the next step is to get rid of whatever coefficient of x squared might have. And in this case, it has the letter a. So we're going to divide out the letter a. Now we then have x squared plus b over a x. We still don't have this term, and we have a negative c over a. Now our next step is to complete the square here by using the technique we have mentioned in an earlier film. We put a set of parentheses. We want to get a binomial square here, that when we do the squaring it becomes this expression, which is then a perfect square trinomial. Now we said the technique was to take whatever term was here, and in a sense squaring this term gives us that. We use this plus sign. Now in the formula of completing the square, we had to take half of our b term. Well, half of our b term would be 1/2 of b over a. Well, that becomes b over 2a. Now, to get our trinomial, once we square this, we said we square this term, get that, multiply these two terms together, and then double it, and then we ended up with this middle term here. And then we squared this term to give us this. So this will become b squared over 4a squared. Now, so far we had an equation. This side equal that, then we transpose that. But at this stage, once I put this here, this is no longer an equation. To keep it an equation, I must add this to both sides. Now, in order to, in a sense, subtract this from this, I have to have a common denominator. So my common denominator happens to be 4a squared. Well, what do I need to do to this term to make this denominator 4a squared? Well, I already have 1a, so if I multiply it by 4a, and I have to multiply the numerator by 4a. In a sense, this is a 1 that I'm multiplying this term by. It now becomes since this is now over a common denominator, I get b squared minus 4ac. And now this is an equation. Now what we said we do here, if we have a binomial that is squared, how do we get rid of, in a sense, that squared sign? Well, we said we take the square root of this side. And if we take the square root of this side, we must go plus or minus the square root of that side. All right, we're tilting a little bit, so let's see if we can straighten it out. So once we take the square root of something that's squared, it just becomes the radicand. And now this becomes plus or minus. Now this is a perfect square, so we can just write that as 2a. And we have under the radical sign then b squared minus 4ac. Now to do our last step, to solve for x, we just need to take this term, transpose it to that side, and we then get x equals a negative b over 2a, which interestingly is the vertex of a parabola, and then plus or minus the square root of b squared minus 4ac all over 2a. And you might say, could you put all of this over the 2a since they are common denominators? And that's our last step, and the answer is yes. So we get x equals a negative b plus or minus the square root of b squared minus 4ac all over 2a. And this is the quadratic formula that we use, the technique of completing the square, once we had it in standard form. Now, this formula is a general formula to solve for x when you have a quadratic equation. But you must identify what your a term is, and b term and c term when it's in standard form, to substitute that into the quadratic formula to get your answer. And we'll leave that to another program.